Here is the coastline of western North America. Let's first draw the water away from the undersea for a look-see at the continental shelf. Good. Now let's wipe away the detritus from the land so we can see the rock surface. Do you also see the cracked and broken edge of the continental shelf? Some of these V-shaped cracks extend right on into the continent itself. These V-shaped canyons are an unanswered mystery to the world of science, but not a mystery at all within this growth theory. The second mystery is the incredible growth of mountains on the separated continents of Earth. Unlike the Moon, Earth has mountains manufactured by the Earth itself. Science's curious answer to this mystery has been that continents rushing about the world crash into other continents, buckling the land into mountains. This is so not true. Continents only move away from each other, never toward. The planet is growing, not shrinking. No continent ever crashed into any other continent. We'll recurve the Earth to the size it was 60 million years ago. That is, after all the dinosaurs died off. The Rocky Mountains didn't exist then. Think of that. So where did they come from? Watch this model, please, as we enlarge the planet. The 10-mile thick hardened curved tectonic plates are longer on the top than at the underside because of the curve. When the crust recurves to a less curved state, the upper crust must collapse in a series of wrinkles. Call them mountains. The center of the continent falls straight down, as you can see. Let's go to North America and let the Earth grow. Watch as the surface recurves, collapses, and folds into mountains. This is how we get mountains. Just as mountains wrinkle and fold, the edges of the continents crack and split. This is what these cracks are. The same recurving that makes mountains also creates those continental shelf cracks. This is Ganymede, a moon of Jupiter. It has a very distinctive surface. The darker areas are older, higher, raised surfaces. How do we know this? First, the darker surfaces have been measured as higher tectonically by the scientific community. Secondly, these darker areas have a greater abundance of meteor hits. More hits equals older surface, as we saw on our moon. I realize this process may seem to be thunderingly obvious to you. It's not to the current scientific community, and they will certainly not buy it easily. So bear with me. As you can see, we are closing the lower tectonic plates to a very dramatic result. Understand, we are only bringing these upper tectonic surfaces together. The result is we have reduced Ganymede by 1/3 of its volume. 1/3, 30%. This just in. When this project began, we had only still photos of Ganymede. Now NASA has a nearly complete map of Ganymede. Some areas are not clear, but for our example, this is terrific. First, we wrap it around a sphere. Good. Now we go back in time and watch as the darker plates move together tectonically. Boy, isn't this a great map NASA's assembled? Look. Let's pick two sides, and not spin them, and we'll just watch them go back in time. The dark plates don't shrink, just the sphere and the lower tectonic plates. It's like a puzzle. I promise you, I didn't change anything. Well, you can see for yourself. Many moon surfaces don't show this process as well as others, so I'm consciously choosing the easy ones. I leave it for others in the future to continue this work.